Welcome back to the Programming Kinect for Windows V2 Jumpstart. My name is Rob Rellier. I'm a program manager on the Kinect team, and with me is
Johan Marion, program manager with the developer tools team.
We're really excited to be here today. I'm a program manager focused on interactions and hand pointer gestures and things like that on the Kinect team. And I've had a lot of experience in UI frameworks. And as Johan said, he's got a lot of experience in the tools that we're going to be talking about here today.
Right.
So our overview for today, we're going to be talking about Kinect Studio version 2. Kinect Studio version 2 makes great strides over V1. It allows you to do recording of sensor data, a lot of different data sources, and also playback of that data, both into the application or just for viewing and for tagging, etc. We'll also be touching on gesture recognition in this session, as well as session 7 with Casey Meekoff talking about skeletal filtering, etc. We're going to be doing some basic discussion of heuristic recognition versus machine learning-based recognition. We've got a new tool that's available with this for the first time with a public preview called Gesture Builder. And Gesture Builder allows you to do machine learning of gestures, and Johan's going to be showing some cool demos, and I'll show you how to code to it as well. So we've got a good session here. So let's kick it off with Kinect Studio, the foundation for recording and playback. We're going to kick off a demo right away, Kinect Studio 2.0. Okay. Let's take it away, Johan.
So let's start with the desktop. And on the desktop, I use the Windows key to launch the Kinect Studio, which should be installed as part of the XDK. And when I launch Kinect Studio, I will connect basically to the Kinect Studio service. And that is the service that lets me record and play back all the data coming from the Kinect sensor.
Let's hold there for a second. So there's a couple services running on the machine.
That's correct.
There's Kinect service.exe, which is not really a service, but it's a long-running process that runs in each user's space, each user session. Kinect Studio service.
Kinect Studio host service.
Kinect Studio host service. Okay.
Right. That is the service that actually does the recording and the playback of the data coming from the Kinect service.
Okay, and it knows how to communicate with Kinect service. And then there's also Kinect Monitor, which you might see sometimes. It's running and basically making sure that Kinect service is always running. If there's ever a problem at all, it'll bring it back to life.
That's correct. So the very first thing we do is we need to connect to the service, and in this case it's called Connect to Target. So we select this and we see all the different streams that are coming off the Kinect sensor that are available for recording. And so I can pick and choose which streams I want to monitor. At this point in time, we're already monitoring. I can see the live stream being fed to the 2D view.
Okay, so yeah, monitor is just viewing inside of Kinect Studio.
That's correct.
Okay.
And so I also have the option to switch to a 3D view, which gives me a three-dimensional space view of what the camera sees, and I can manipulate real time as the data comes over the wire.
Always love that 3D view.
Right.
So we see the body data there. We see where the sensor and the runtime think the floor is. We see our depth shadow.
And we see the frustum also, which is basically the field of view that the camera sees.
Okay, those red lines are the frustum.
That is correct. At any point in time, if you want to change this, you can right-click this, get a context menu, or go to the toolbar, pick settings, and you get a list of all possible configuration or rendering settings that are available for the 3D view, and the same in the 2D view.
So if you're monitoring, right now we're monitoring body and depth and IR, it looks like.
Correct.
And so if we change, can we change the order of those settings of those viewers, and that's the ones we would see there?
That is correct. So right now you see the 2D view, and I'm seeing the IR feed basically, and the depth data being exposed as a color ramp on top of the IR data.
Right.
If I wanted to change that, I just switch to a gray ramp, change it, and I see the setting immediately take effect. Now, if I wanted to show a different view, let's say I want to, in this case, we're not monitoring depth, but let me take bodies, and I want bodies to be rendered on top of everything. I can say move to the top, and now I get actually the body data rendered on top of the depth data that I had.
Gotcha.
And the same applies again in the 3D view. There's some additional settings. I can zoom, I can do a zoom to window. On the 3D view, I have a couple of standard views that are available in zooming.
Gotcha. Yeah, the UI's gotten a lot more flexible than the V1 code base.
That's correct. Anytime we want to change monitoring streams, we have to stop monitoring, change the settings, Once we're fine with whatever new settings we want, then we just resume monitoring. From this tab, I can also switch to recording.
Oh, well, can you show me more about views? Just change.
Sure.
Let's dive into some configuring a new view.
That's fine. I can show you what the new views look like. So with this UI, we've also made significant changes to let you customize the view. And one of the features I particularly like is if you go to File Settings, View, and here you see tabs for the views that are currently in place. So we have a recording tab, and it shows monitor and record that we have. But I can say, I want to create my own view for this. Let's say I create my view, and I want to do a separate monitoring view. And I personally prefer to have a 3D view up front, maybe the 2D view stacked on top, but it becomes a secondary tab. And I can drag over my tab, call this my Easy Monitor tab. And now I have a custom view. When I go back, I can see now on the top I picked the tab, which is the Easy Mon. I now start off with a 3D view. I have the option for a 2D view. But what is really nice about this is in a scenario where I say I want a little more diagnostic, and I can come in and right away put side by side a 2D view. When I now go back to the Easy Monitor view, you see I have both views side by side. And I still have the option at that point in time to switch between different views.
Right, and so if you had two 3D views side by side, you could go ahead and have them looking from different angles.
Right.
Whatever you need to visualize what's happening in your scene or in your recording.
Right. Quite often we see where people customize a view. In the left-hand view, they would have 3D followed by a 2D. In the right hand, they'd have a 2D followed by a 3D. And so at any point in time, they can switch back and forth, but they're always having the default layout that shows them a 2D and a 3D side by side.
Cool. I want to talk a little bit about, before we jump into recording, I want to talk a little bit about the recordable data sources here.
Sure.
On the slide, we talk about color, audio, infrared, and depth as being recordable.
Right.
Can we flip over to the slide, please? So we have a set of data sources that are available for recording.
That's right.
So color, audio, infrared, depth are available for both record and playback.
There's a small caveat there, and that is at this point in time, recording of color is not in this release.
Sure, yeah. In this public preview,
correct.
color is not an option to record.
Right.
And you can see some of our numbers there that we have for how many megabytes per second. Color is, if you write to a file, how big it is. That's how much it actually takes over the USB hub as well, or
right.
the USB
right.
Audio as well. Infrared as well. So now
right.
infrared and depth both don't come off of the. Somebody had asked a question earlier about how much travels over the USB wire versus how much would be stored in a file. It'd be almost this much data traveling over the USB hub.
Well, there's actually just a little bit more because there's command and control that we send back and forth to the recording service. But basically, the minute the data starts flowing, the sizes you see here are basically the sizes of the data that travels over the wire. And color being, of course, the largest, followed by depth and IR, which are about the same frames. And audio comes in at a very small portion, of course, of the total data volume.
Gotcha. And we've got these purple data sources, body index, body frame.
Right.
They're record only. Why do we have some record only?
So in many cases, you have data that you say, I'm interested in seeing the data from a diagnostic perspective. So I can say, I take the body index data, or I take the body skeletal data, and I want to see that in my debugger. But we don't really play those data streams back. What we do is we take the infrared and we take the depth data, and we play that back to the Kinect service, which then again reinterprets, rederives the body data. And
so if you want playback to be playing back skeletons, you need to
preserve
record
your depth.
Infrared and depth.
That is correct.
And that will play back with the ST engine line.
Right. It's what we call a derived data stream.
Okay. Gotcha. Okay. Well, let's jump in and see a demo of some recording and playback.
Sure. So again, let me switch to Kinect Studio. And I have Kinect Studio. Now I switch over to, let's go back to the recording tab, and I pick record. I want to record, in this case, depth and IR. I don't have to record the body frame because, as we said, I could use it as diagnostic or as a reference data.
So later on, when we get to Gesture Builder, that's an ML-based tool that does work on pre-built body frames. So you do need to record that when we're talking about the Gesture Builder later.
That is correct. If your intention is to capture clips that you will use with Gesture Builder, you have to collect at that point in time the body frame data. So what we're going to, speaking of a gesture builder, what we're going to do is I'm going to record a clip that demonstrates, take a simple gesture, hand over head, to detect the hand over head. And so we're going to capture the body data. And then we're going to use this clip later on when we do the gesture builder. So I have my stream selected, and I click record to target, and I will slide back in front of the sensor here, and we're going to capture this clip.
Great.
So hit record, come in front of the sensor. I now raise my hand above my head. Now, what good would a gesture detector be if I only did one hand, both hands over the head? What we don't want is to detect a gesture where my hand would be off to the side, so we'll include those in the gesture clip as well, because we want to use those as negative training cases. And so this is the end of the recording. Okay, so now what we have here for the recording, you see a timeline, and on this timeline we have a number of different swim lanes that we call available. The first swim lane that we have shows...
Actually, before you go there, I'm sorry.
Right.
Those recordings all go into a set directory, right?
They do go in the set directory. Right now, the directory is specified when you launch the service. So by default, it goes into your users folder, Kinect Studio repository. For the final version, we will have basically the option to update that directory so you can save it to any other location that you want.
Okay, gotcha. I think that's Documents, Kinect Studio repository.
That's correct.
Okay.
Okay.
So sorry, go back to the swim lanes.
Yes.
Here.
So we have the different swim lanes, and so the first thing I have is I have what is called the in and out points, and so they let me control of my recording what portion of my recording that I will actually use. So if I now want to play this back, the range bracketed by my in and out points will be the range that is played back. I can also, at this point in time, specify looping it or looping count. So let's say we take a very short range here for playback, and I can set a loop count, let's say of 10. When I now hit playback, it'll just play this small section. It zooms in on the section, and it plays that small section, and it will iterate over it 10 times. Another option we have is there's another band underneath here which is called pause points. And as you see, as I click in here, these are markers that essentially will tell the playback where to stop. So when I now restart and I'm playing this band, I actually selected pause points out of the range. When I select these within range and restart playback, you see the cursor advance here, but it stops at the pause point. I can now resume playback and it runs to the next pause point. So I can have multiple pause points. And why is this interesting is when I have my code and I'm debugging my code, I'm stepping through my code and I have the matching playback to go with it, I can then pause the playback automatically at this point that would correspond to where my code is. And then I can also single step from that point onward.
Gotcha. So a lot of times people should have their test team or their customers file some bugs with some Kinect Studio clips perhaps, and you debug the problem areas you have.
That's correct.
And then you sit there with your code and you debug the clip and figure out what was wrong with your code and bend it into shape.
Right. Another thing that I can do is, speaking of testers or even other developers, is that I can now annotate this code. I have this recording and I can go in here, and the last rail that I have is add a marker. So when I click on this bottom line, I get a marker. And the marker lets me attach metadata. So I pick this marker and I can say, show me the metadata, and I have a number of metadata views, and I will pick, let me just pick
Okay, so right here you're choosing actually which metadata window to display it in?
That is correct.
Okay.
So there's, like I said, there's a multitude of metadata windows, and so here we see now this marker, which was called new marker, is also now visible in this window.
Right.
I can go in and I can edit the name. Let me call my marker. And now I can say attach metadata to this. And I can say
so you can do name value pairs of all sorts of different types here.
It won't go with food, but let's just go with gender in this case. And I can say it is a text field, and I would say this is in this case a clip of a male.
Right. Okay.
I can
go ahead.
I can also attach metadata that is tagged as PII, personally identifiable information. And as private information, for instance, you have the person's real name attached to a clip, and later on you want to strip that off. So we have a category to separate this out.
Okay, and there's a tool, is it Chaos Convert?
There is Chaos Convert, which is our general tool for converting clips or And that will allow you to, for instance, strip off color or to strip off metadata, depending. So it's more of a clip management kind of tool.
Okay.
Okay. And so the other thing I forgot to mention, Rob, is that, with the swim lanes, you see you have the enable button. When my playback is stopped, I can, of course, choose which streams to play.
Gotcha. So even though you've recorded it in IR in depth, but you don't need to play it all back.
That is correct.
Okay.
Okay.
Gotcha. Now, and the metadata can be at the file level. You can actually go down even deeper, down to the individual stream level.
The metadata we've attached here is to a particular stream, but I also have file level metadata, and I can now also show that in this window. At this point, since we haven't saved off the recording or haven't attached anything, you see there really isn't any metadata attached. But again, here, personal identifiable metadata or public metadata, I can attach it in just the same manner to the clip.
And one of the key things that you've told me about the metadata is that when somebody's using programmatic access and playback that we'll talk about a little bit later, these metadata markers work very well for that. So tell us about that.
Right. So let's say that someone gives you a clip and there's metadata attached to it, and I want to know, for instance, where there's a problem that's associated with it. One of the easy things I can do is I can, for instance, in the UI, even right-click on it and say add a pause point, but that can just as easily be done with the APIs. I can say enumerate all the markers that are there. I can search for a particular marker by name. So if I don't know what, for instance, the in and out points are on the clip that someone had said, or I'm concerned someone may have changed them, I can explicitly name my markers. Here's where the problem begins. Here's where the problem, for instance, ends. I hand this off to my developer or my technician, and he can then just say, okay, set the pause points, set the endpoints to these markers, play back from here. And just like we can do in the UI, we can access these using the APIs.
Gotcha. Cool. Okay. So that's a run through. Is there anything else about playback or record that you'd like to show off right now?
There's some additional control points or additional functionality around these pause points. I can disable all of the pause points. I can re-enable all the pause points. Remove them all.
Great. Can you show playback happening here if we run something from the SDK browser and just run a sample app, and let's just see that in action, because that's one of the key benefits here. It's not just playing it back in the tool.
That's right. So launching the SDK browser, let's pick Body Basics, for instance.
Sure.
So now we have a live stream coming from the sensor. Let me just bring this to the foreground, and we will take our clip. We have it set to 10 iterations. We take this short section, and we will launch this. So now we have a playback running, and this is basically what the title is now, or the application is receiving based upon the playback, and it's going to iterate that over the 10 iterations I have.
Great. So right there, we've done that recording one time. We're able to sit there and code it, and
that's correct.
The one amazing feature now is I can take that on a bus, or a train, or a plane, and I don't need to plug it. I don't need to have my sensor with me even. I can go work on my pre-built recordings. That's fantastic.
Right, and that's really the strength of this tool, is you don't have to stand in front of the camera all day long.
Cool. So a few things, just to wrap up some of the basic things about Kinect Studio, some of the major improvements. We've now added the ability to record audio. V1 didn't have the ability to record audio, and many people are happy about that, especially those people who have speech scenarios. Playback works without the sensor attached, as Ben was saying earlier in the day. He's really excited about that feature, and so are we all. And we've got API access to do playback and record on all the Kinect Studio APIs. Kinect Studio is actually built on top of those APIs?
That's correct, Rob. So all of the UI is built on top of these APIs.
Okay.
And so if you can do it in the UI, you certainly can do it in the APIs. And actually the APIs go a step further. There's many features that you can do using the APIs that are not necessarily exposed in the UI, but we believe the UI covers the most common scenarios.
Gotcha. So you can open, iterate through files, play them back, record those files, and more. Now, those APIs are in Microsoft.Connect.Tools.dll, I believe.
That is correct.
And that's installed in the Microsoft SDKs, Kinect, version 2, Tools directory, and then under Kinect Studio.
Under Tools, like yes, Kinect Studio.
Okay, gotcha. So I'm really excited that we've got that as well. That was a common request in V1 as well.
Okay.
We're going to talk about gesture recognition. gesture recognition, once again, now that we've been able to record and play back things, your application wants to understand when there's a certain pose or a certain gesture that's performed by your users. There's two major approaches there, heuristic and machine learning approaches. I'm going to code a simple example of a heuristic detector, and then we're going to dive in and learn how to do that with machine learning as well with this great new tool called Gesture Builder. Then I'll take that back, I'll take the baton back, and I'll try to programmatically call the gesture recognizer, the ML developed detector, and I'll try to not only call my heuristic detector, but I'll call the ML-based detector as well. So let's get started. I'm going to start by running the SDK browser. I'm going to start with sample code base, body basics WPF. I'll install that to documents, open up body basics, and we'll go ahead and modify that. Now, once again, when you're building something that's doing gesture recognition of skeletons or something like that, it's great to start with a sample that already has the coding loop set up for you. So let's take a quick look at things here, and I'll try to give you a little more space here to see in body basics. But in body basics, let me get down to some of the main things. We get the sensor. We're going to use a coordinate mapper to map on the display. I'll keep going. We're going to use a body frame source reader. We're going to create a bunch of bones, definitions of bones here between different joints. We're going to create a bunch of different colors. We're going to open the sensor. In the main window loaded, we're going to listen to a frame arrived event, and let's just go jump to that frame arrived event, reader frame arrived. Inside of there, as we saw earlier in Jesse's session, we're going to acquire a frame that's going to give us a body frame. We do it inside of a using block, and we make sure to check for if null, to make sure it's not null, to make sure we're getting it in time and not falling behind. If it's, then we basically will go ahead and instantiate our collection here. We copy the data out of the body frame by calling get and refresh body data, and we say data received is true. And then if it's true, we do a bunch of stuff. We basically go filter, we loop through all the bodies. We say if it's tracked, do this stuff. So this is where I'm going to go write some code. Right now, the current code, if I just run this code, the current code shows hand state with the open circles. I'm going to build a detector so that it shows me when I raise my hand above the head, it changes to green, and it changes to red when the detector is registering false. So we'll do a quick bit of code here, and I'll create a function called, I'll just say bool is right hand over head equals is hand over head, and I'll pass in joint type, and I'll start by passing in the left hand, and I'll also pass in the body, or I'll just pass in I'll pass in the body. I'll create that function, generate a method stub. I'm going to call this function twice, so I'll do a quick copy paste. Is the left hand over the head? Is head over the body? And I guess I'll fix my first code there to make it hand right. And I'll press F12 on this function to jump to it. And let's see if I can write this code correctly. I want to say head Y position. The head Y position is actually, let me just say var head equals body.joints joint type.head. So I'll get the position of the head, then I'll get the position of the hand that I just had. The position of the hand is whatever I passed in as the joint type in the parameter. And I'll say tool is detected equals hand.position.y greater than head.position.y. See anything wrong with that, Johan? Does that sound right?
Looks good.
Okay. That's still red squiggling me. Oh, I didn't return any code paths.
Is detected. Yep.
There we go. So we're going to return is detected. I'll do a quick compile. We're all happy. That's great. So right there, we've got a quick little detector that we wrote. We need to. We've called it both of these places right here, and now we're going to change draw hand to just render that. So instead of passing in these different hand states, we're going to pass in is right hand overhead. And I'm going to make this, I'm going to do is right hand overhead and is left hand overhead.
Right.
I'll make it the opposite. And I'll pass in this other bool. Let me go to the draw hand, and now instead of getting a hand state inside of here, I will say is detected. And so if it's detected, I want to have the hand open brush, which I know if I press F12 is RG, that's green. Hand open brush is green. So I'm basically going to say, hey, if it was detected, it's that. If it wasn't detected, it's going to be that. And there is no third state. There is no lasso state. Okay. We compile. Let's see if this little detector is going to work. My hand is below the head, and as I get higher, boom, hey, it turns green. And I've got my detector. And that's a simple little detector, but you'll notice that, hey, it doesn't work fantastically. I'm going to need to keep tweaking this and tweaking this and tweaking this because I don't want this to be hand overhead. That's like barely hand overhead, right? I want people have to raise their hands. So really, I should go change the code and say, oh, well, maybe if I'm within a certain distance of the shoulders or a certain distance at the midpoint, I'd want to support that. And I'd want to keep tweaking this thing to make sure it's right for whatever gesture I've chosen. So that's a quick example of a heuristic detection of a pose or a gesture.
Okay, let's take a look and see how we do this in Gesture Builder. So Gesture Builder is a new tool that we introduced in this SDK, and it takes a data-driven approach to this problem. So it uses the body data that we previously recorded. And the way Gesture Builder does this is we create projects which represent the project for my application similar to Visual Studio. But then I also have the solution is similar to what we have in Visual Studio, but the project refers to the individual gestures that I want to build a detector for.
Okay, so one solution, I could define 4 gestures or as many as I want there.
That's correct. And so the way it works is you take the body data and you load in Gesture Builder, and then we will tag this data. And tagging would mean we associate metadata to the body to go say, here's where we believe that the body data is valid. And then we take this tagged metadata and we run it through a process called building or training. And what we do there is we take DML technology, and there's different kinds, and we basically pass all the tagged body data to the trainer. The trainer observes all this data and tries to extract a pattern from it. And then as the end of the build, what we get out of there is a gesture database or a gesture definition. This gesture definition is then used by the runtime to go and say, okay, now I know what the definition of that gesture is, so give me body data real time or live. And then it runs the same data through the detector that was based upon what was generated as part of the build. And it will tell you then in the results whether or not it detected the gesture. There are really 2 types of gestures. There's what we call discrete gestures, and those are detected using a technology called ADA Boost. And then there's another type of gesture, which is more of a progression, such as a golf swing or a baseball, where I have a start position and I want to know how far from my start position I've moved through the gesture. And that is done using the RFR, or random forest regression.
So the example that we're coding here, the hand overhead, is a discrete state that we're detecting.
It can be done as a discrete state. I can choose to do this as a progression. Let's say that I want to know how far above my head I want to be. I could use an RFR detector for this. If only I care about am I above my head, then I just go with an AdaBoost detector, and because I'm looking for a given state.
Gotcha. So let's talk about the workflow.
Sure. Normally, so as I alluded to, is you start by recording body data with Kinect Studio. Once you have the body data, you will load this body data, this clip or collection of clips in Gesture Builder, and you will tag this, and we'll go through that in the demo. Then you go through a build or analyze step in Gesture Builder, which actually lets you build the database. The analysis is really the refinement process. So after I've built the detector, I may find out that it isn't quite where I want it to be, and I may want to add more clips or tag additional data and then refine it. And so ideally what I have is I have a set of clips that I will train on, and then I have another set of clips that I will test against. And the analysis does the comparison between what I've trained on versus what I'm testing against, and says, yes, all these test clips that you didn't train on correlate closely to the detector that you've built, or are still not being detected. Therefore, I would have to extend the set of clips for which I trained.
Now tell me, if I recorded, how many clips do I need to record to ML?
Okay, it's a recurring question. It's a very interesting question because you'll see as part of the demo we're going to go through this, and with one clip we can detect a very simple motion like hand over head. Now, when I have only that one gesture, that's not a problem. When I, of course, have multiple gestures and they are more complex, like I have a baseball swing, when I'm talking a baseball swing or a golf swing, right away I'm talking maybe 3 gestures. I'll use an AdaBoost to detect the start. I'll have an RFR detector for the progression in between, and then I'll have another AdaBoost for the ending. But then I want this to work for adults and for children, for people up close to the sensor or people further back from a sensor. And so now I'm starting to have more clips that I need to test and train on. Typically, we look for a ratio of about 2/3 for the testing. Yeah. Well, actually, we use about 2/3, for training, and about 1/3 to go test the clips to see if it actually still meets the criteria that we described.
Gotcha.
After we've done build analysis, we basically go and do preview. And so preview is a quick way to say, I don't have a runtime ready yet in my application. I just want to load this database and see how well my detector responds. And when the detector responds favorably, I say, okay, maybe I'm ready for production. When I see that I don't get the desired results, maybe it is time for me to go and collect additional clips, or in some cases, I may actually have to go train out certain negative behaviors. So, and after I've done the preview, the last step in this case is to go and integrate the runtime in your application and load this database.
Gotcha. All right, well, let's jump into Gesture Builder.
So let's go see what that looks like in Gesture Builder. So I'm going to start Gesture Builder. It wouldn't help if I spelled
Gesture Builder, like Kinect Studio and like the SDK browser, are all installed and just quickly accessible via the search bar.
So I start by creating a new solution. And let's call this MVA demo. And in this, I create a project. And so, as I said, you would create a project per gesture. And in this case, we will say this is the hand overhead detector. And we will use the AdaBoost because we simply want to know the state. If I wanted to have more progress in as how far my hand has moved over my head, I could switch to an RFR progress detector. The other questions we have to answer are body side. Does it matter in this case that I want to differentiate between left and right? And in this example, I can simplify some of the things you did. You had in your code 2 cases where you said, show me for left and right detector. I can just say, do for any side.
Yeah, maybe left or right isn't significant.
It may not be significant. Yeah. And in this case, I can also say duplicate or mirror the data during training. So when I do this, I don't, if all my clips were, let's say, from a left-handed recording where I move my hand over my head, I can simply say duplicate it here and it'll use that clip, it'll mirror the data, and it'll use that for training. In this case, it says use hands. This really pertains to the hand state. And for this sample, we don't care whether the hand is open or closed, so I don't have to check hand state. In this case, I do want to use the arms, but what I want to ignore, for instance, is lower body. And what that would allow me to do is to detect the hand over head state, even whether I'm seated or whether I'm standing. And at this point in time, I confirm. And I create a project. And now when I have this project, I need to go start adding the training data, the clips with the body data I've recorded. I say add a clip, and we go to, let's pick the clip that we just recorded.
Okay, great. So we have our ZEF file, our XEF file.
This is the ZEF file that we just recorded in the studio a couple of minutes ago that has the recordings in it. And as you see, I click on the timeline and I can step through the frames. Let me go to the initial frame. And here you see my hand starts to go over my head. So I go here, select this range of frames.
So you're shift arrowing there.
Shift, left arrow, or right arrow.
Yep.
To select a range. And now I want to tell the system that this is the range of clips that will signify a hand overhead state. And so because this is an ADA boost detector and we only care about the state of this, I can come to the right hand side here, properties, and I say the hand overhead state gets a value of this case, and I say this is...
So if we had multiple projects or multiple gestures in this solution, we would have, if there were ADA boost, we'd have multiple entries there, is that correct?
So if I have multiple gestures, I would have multiple projects.
Oh, you'd have to add that same clip into the same into different if it applied to both, you'd add the same clip into multiple projects.
That is correct.
Okay.
Because I can have a single clip that has multiple gestures in it. Right now, we've restricted ourselves to the left and the right hand movements. I could also have jumping jacks in here if I really wanted to, and then use those in another detector.
Okay, so you're marking your second session here.
I'm marking another one, and we'll mark this as true. And let's go both hands here overhead.
So your taggers are different than your developers.
Right.
That's one interesting thing about the ML approach.
Right.
Is that you can have
and
people collecting all sorts of data, taggers doing things, and these aren't your developers, and the developers integrate the final gesture and tweak it and add additional heuristics onto it, etc.
That's correct. Then they don't need to know anything about coding.
Right.
But the other important part, for instance, in this case, is I have a hand overhead, but I did not want this clip to be detected. So by not tagging it in this case, it counts as a negative tag value. Similar for this. It's an outlier value. I don't want that in my clip. So now we are essentially done with this tag clip, and I can say save this tagging information, and I come to hand overhead and I say build this. And what this does is it builds a GBA. It is a gesture builder analysis database. There is also, when I have multiple gestures, I can build what is called a GBD. And you can think of it, for those of you who are C programmers, the equivalent of an OBJ versus a lib. It's the individual gestures versus the collection, the library of gestures. And
the API calls I use over in the app, I load a GBA or GBD, doesn't matter. The GBD will have more gestures.
That is correct. The nice thing is that if I were to create a collection of gestures, and I can share that with you, and you can say, I have 5 gestures in this database, but I only care about 3 of them. By launching Gesture Builder as a command line tool, I can manipulate which ones of the gestures I preserve in the database and which ones I want to strip off. So in this case, we're saying create the hand overhead database, and it is building, it is currently going through this, and you see the build process, and it's looking at what are called classifiers, weak classifiers. And what is also good here is that Gesture Builder does an analysis of all the data that you will throw at this. And you can use this even when you do a heuristics approach. And we can talk about that some later. But this is really where it does the analysis of all the data. And based on this, it will determine what are the parameters or what are the...
Oh, I see. It says right there, top 10 contributing weak classifiers.
Right. So it's selected out of all the classifiers that it builds, it selects these 10 classifiers as the ones that it will track. Mm-hmm. And so these coefficients that it computed, the f-values, the alphas, and whatever, get basically written to this database, which is loaded by your runtime and then used by the runtime to detect this. So now that we've built this, how can we quickly go and validate this? And I can say, do a live preview. And what this does is, without leaving the tool, I pick the database, and it now launches a tool called VGB view, which is also installed as part of the XDK. And you see we get a live feed, and I have a body tracked on right now. And we see a window here that says hand over head. And that really measures the response of the detector. Right now it's an AdaBoost detector, so let me slide further in view of the sensor, and I start to raise my arm. And you see the minute I raise my arm, I get a response, and it gives me a positive response. Whether or not it is my left or my right arm, I get a response. Both arms. If I move further out, those cases disappear. So sure. Without writing any code here, I was able to achieve what you did in code for some complex gestures. This is a preferred approach. For some of the simpler gestures, maybe coding is easier. The challenge always becomes when, scenarios where I have to consider left versus right, or I have special case where I say I want to really narrow the definition of the gesture. When I write code, I have to write more code. In the case of a machine learning approach, I have to add more data, or I have to have more precise tagging.
Gotcha.
So that is the end of the gesture builder demo at this point.
Gotcha. So as you mentioned, gesture is a coding problem. Basically when you use heuristic, you make it a coding problem, and that makes it. Developers have to do it. As you're developing and you want to tweak, you have the power to do that, but you're making lots and lots of special cases inside of code, which sometimes is great and gives you the power you need.
Right, and so that's a little bit the determination. When you start a project, the question is, do I have very strong coders? Do I have a clear understanding of what the gestures that I want to do, and I just add more lines of code to it to special case it? With machine learning, it comes down, it's really a data problem. How much data do I have, and how well do I tag?
Right, and it's especially strong, though, when you have signals that aren't human understandable. So you've talked about like a baseball swing. If you look at skeletal tracking with a baseball swing or golf swing, the skeleton is not going to be doing totally dependable human logical things throughout that swing. So ML can kind of sort through that.
That's right, especially when I have body occlusion. So let's say I have a golf swing and I start to turn at 90-degree angle towards the camera. The skeletal tracking has more difficulty with those poses. What machine learning does is it can extrapolate the data between maybe a starting position and a midpoint and an endpoint. So there are clear cases where the machine learning approach is much stronger. Now, in the simpler approach, you can quickly say I can whip out a couple of lines of code and I can maybe detect a start and a beginning. But we've seen clear cases where machine learning has an advantage, and there's other cases where we say the cost of machine learning, just the sheer number of clips I need to add to qualify or to refine the gesture, outweighs the benefit as opposed to code. So it becomes a trade-off really depending on your gesture. The main takeaways really should be that it'll keep your gesture simple. Try to make it so your gestures do not interfere with one another. If I have gestures that are very close in terms of body movements, it becomes a real challenge, both for heuristics or for machine learning. If I have gestures that are very distinct, then it is just a matter of, do I want to go the data route? Do I have people who can do the tagging? The challenge with data is also the quality of the tagging. If your tagging is not very accurate, your results will immediately be off because that gets reflected in the detector. If I do it through code, I have the same challenges, but with code, I tend to put up a debugger. I can step through it and I can fine tune. So it depends on your preference on how you want to work.
Gotcha. Well, I'm glad that we have the tool available for people to give it a shot and to use ML as a tool in their toolbox now. I'm going to quickly show a little bit of code in just a minute of how to call gesture detector from code. And I've pre-built this. I'm not going to try to build it anymore. Let me go search for gesture builder. I've declared a few variables here. There's a visual gesture builder frame source and a visual gesture builder frame reader. In the hold on, let me go look for in the window load. Main window loaded. I go ahead and create that frame source. I initially set it with, I pass in the Kinect sensor. I pass in a body tracking ID that's unknown so far. You need to attach it to different things. I'll go ahead and find my database path that we pre-built here, a GBA file hand over head, and I'll pass in the VGB builder database over there. I'll loop through the VGB database, finding all gestures. In this case, we had one gesture.
Right, and if I was just going to interrupt you. So if you have a multitude of gestures, this is also where you can filter which gestures I want to turn on and off. So if you want to build a library and share that amongst developers, this is also where you would do this.
Gotcha. And I can go look at more metadata about the gesture here to see what type it is, what the name is, etc. So I go add that into the VGB frame source. I create a reader, and I'll listen to the frame arrived event. And in the frame arrived event, I'm going to basically acquire the frame like always. I'm going to get my gesture results from that frame. I'll look at the gesture in the key of that result, and then I'll get result.value is the discrete gesture, and it's either discrete or the continuous.
Correct.
And so based on that, I'll get confidence or some sort of progression value.
You get a confidence, and so if it's an ADA boost, you get a discrete gesture. Essentially, gives you the response to the true/false. If you have an RFR gesture detector, you'll get a progression that says how far along you are. Now with RFR, instead of just, you're not bound to 0 or 100 or 0 and 1 in terms of values, you can specify a positive or negative range if you wanted. So
gotcha.
let's say you had a steering gesture, you could go from -1 to +1 depending whether you turn left or right.
Right. So there is no sample for this right now. We'll try to post this soon. What we did here is we added a reference to Microsoft.Connect, that visual gesture builder, which shows up fine as an extension. The one trick that we had to do is we had to add AdaBoostTech.dll from that tools directory where Kinect Studio is, or where Gesture Builder is, and or the RFR if we're using RFR, and we needed to add it into this project. But the trick was, in the bin directory, we basically needed to make it inside of a directory called VGB Techs. So we'll publish a sample here and make sure that you guys have guidance in here. We're really happy this technology is available now, so let's see if we can take a few questions. Are there any questions on ML that we can fire our way? Can you mix different angles of the camera and the people? If not, what's the optional capture position?
The optimal capture position will depend in large part on what it is you're trying to achieve. If I have most of my gestures that are confined to the space right in front of my sensor, my angles would not matter too much. If, of course, I plan on capturing the broader space in front of the sensor, and I say I want persons to be detected on both the left and the right-hand side equally, yes, I want more clips at that point in time in my training set.
Gotcha. Another question is, can you use Gesture Builder in Unity apps? Not in this release, not in this preview release, and we'd love to hear your feedback if you want to do that. Please give us your feedback.
Right.
So can you build apps that build dynamic Gesture Builder databases, and what languages are supported?
Okay. Currently, we have a managed API. We have WinRT APIs. They are accessible in both C# and C++. We also have JScript sample at this point in time that's in the works.
So that's all for the runtime analysis of
that is all for the runtime analysis.
Gesture detection.
Correct. Yes.
Okay. Can you does any part of the Kinect SDK, including Kinect Studio or Gesture Builder, run on Windows 7? And no, I think we only allow installation on Windows 8, and we haven't tested heavily there.
That is correct. Windows 8 is the only supported platform at this point.
Okay. Okay. Great. Thanks. Oh, we've got one more question coming in. Thanks very much for a great day so far, people.
Yes.
One more question coming in.
Sorry, slow typer.
Okay.
Is it fast enough to detect a baseball swing?
Well, I mean, you detect at 30 frames a second. So if you have a detector, you have all the frames captured and you tag them properly, use RFR, yes, you can detect it fast enough. Now, what you do need to take into consideration is, for instance, do I have additional detectors for the start and stop of a baseball swing? And if I do, every one of these detectors will take a certain compute cost. So then it really comes down to what kind of hardware is going to be powering my application.
Gotcha. Well, thanks, Johan. This has been great. I'm really happy that we've been able to talk about the tools. Great Kinect Studio version and Gesture Builder for the first time for our developer audience. And we will see you next session in another 10 minutes. Thank you.